All right, there's a whole bunch of new PID tuning softwares out there, but are they really PID tuning softwares? Well, not all of them. A good bit of them, these you can see on the screen, are really PID analysis softwares. They take your Blackbox logs and your flight from your tuning session, and it will go through and analyze the log data, give you step response, spectrographs, all the stuff you can see down here down below to help you analyze the flight characteristics and do the tuning yourself, really. And many of these, if not all of them, are really based on the OG PID Toolbox, which has been out for years by Brian White. PID Toolbox used to be open source and freely available. Now it's it's a part of his Patreon subscription for $6 a month, or just $6 for 1 month if you want to grab it that way. So it's not really expensive in any way and shape form, and it's been out there. It's the first one I'm aware of in the FPV community, at least, that looked at step response and a number of other things. It really begs the question if these other ones are not just really iterations of it, taking the open source code that was there at the time and vibe coding them into another package, shape, or form. That all being said, after going through these, there's a number of differences between them all and a number of unique and good features on some of them. So in this video, we're going to continue the series and go through the software that you see up here and kind of give you my thoughts on what's good, bad, what doesn't work, what does work really well, and just kind of give you a breakdown of everything. A lot of these are web-based UI apps, so you can just go to a certain website and it's all there. You can load your log, so very easy. You don't have to install things. And we will compare them against the OG PID Toolbox to see what the results give. Do they give the same result? Because this is kind of tried and true and tested. Brian is definitely an expert tuner and really knows what he's doing. By and large, like I said, he's probably the one that I would think developed the core basis of this, that the rest are kind of a derivative of to begin with. Now, before we get started, what we're going to be doing is loading some log files in, and it's going to be of this quadcopter, which we used in the last video in this series. In the last video, we looked at the different input types: wobble, chirp, or just sharp step inputs, and what some of the differences are that you get in step response. The conclusion of that testing, at least to me, was that just implementing sharp stick inputs produced better results, or more accurate results, for step response tools like this over here in your flight analysis for your PIDs. So just doing sharp stick inputs. Now, if you haven't seen that video, go ahead and check out the playlist down below. We'll have that. And then I also make a link to an old video I have about doing sharp stick inputs for PID analysis. So kind of comes back to that. The chirp and the wobble are good for repeatability, but the sharp stick inputs generally just do better at capturing the data better for getting good analysis for your step response graphs for things like this. So that's what we're going to be using, and that's why we're using that. And again, this is the quadcopter it was on. We're going to have this tuned, untuned, and see some differences. So since PID Toolbox is the OG, let's start with the OG. PID Toolbox is, again, developed by Brian White. I think it was developed in 2018, so it's been out there for quite a while. I believe before COVID. Time flies. As I mentioned before, PID Toolbox used to be an open source software. He kind of rolled that into his Patreon subscription. So if you're for PID Toolbox Pro, which is the only thing under development. So if you're interested in it, you would check out his Patreon, and I'll put down links down below. For I think it's $6 and change a month, or just 1 month, you can download PID Toolbox and install it in your system. Obviously, you won't get updates if you'd stop your subscription. You'd have to re-up the subscription and get new updates for it. But you get other things beyond that. Brian does weekly webinars where you can connect. You can ask him stories, or ask him for advice, ask him how PID Toolbox. He has a number of videos on the software out there, which a lot of these other platforms don't have that. Like, you can get a hold of Brian. He's in the community. You can see him around. He does professional tuning if you wanted that as well. He does a lot of cine lifters, so on and so forth. So he is a readily available, tried and true, trusted resource, has been in the community for a while, contributes to Betaflight. So this whole like, hey, it's paid, that's bad. Well, you know, if that's not for you, then it's not for you, but it was definitely an inspiration. I think PID Toolbox is an inspiration for almost all of these other packages. So with PID Toolbox, you do need to download and install it. It is available for Windows, easily. Mac, a little less easily. He does have that available now, though. You have to do a couple things to get it to work, but he has instructions for it. And I believe Linux is available in Linux as well. So it's not a web-based UI. You have to install it. There is versions. He is looking at doing some AI assistant stuff in the next release, but he's vetting it. He's not just, he knows what the AI should be giving back. So he's very skeptical and really trying to vet, is it giving back good data? Is it he doesn't want it to be a gimmick. He wants it to be actual real help. And that's some of the benefit with, again, PID Toolbox and Brian. He's an expert in the area, and he's not there just trying to make a buck. He's trying to provide value. So anyways, install PID Toolbox. Interface looks like this. You can open a log. It supports all kinds of different firmware, from Betaflight to iNav, ArduPilot, I believe KISS as well. I'd have to look, but it supports all the different firmwares out there. You can open multiple logs, and then you can kind of pick them here and look between them. This is the actual log traces. Most of these softwares work very similar to this. And I'm not going to go through top to bottom on all these softwares and all the features, but just to give an idea of the PID tuning part of it, you can run a step response tool. And in that step response tool, you can run one or multiple logs. So I can look at this for, this is tuned, this is untuned. I can run those together at the same time and see the difference. I actually had those, the one run, so I have to hit reset and run it again. But you can see this is this quad in red tuned, the orange is untuned. It's just the default, and then we have a little overshoot here. It's detecting that. There is some Y correction stuff that you need to do, generally in my experience, to get it to work correctly. And then there's some other settings in here for like how big of a window. Essentially, this is a window that goes through the log, and it's a 2-second, looking at a 2-second gap in time as it runs through the log, and it's looking for stepped inputs. When you're looking at these graphs, another point I wanted to point out with this, that we're going to see in other software as well, is that it's not just one. You're looking at an average by default. So if I click the raw button here, this is all the data that it's looking at. Then it averages to that one line that you see. So you can see we get a way variety of step response stuff here. And again, it's just averaging that out. It's almost like if I zoom out far enough, it would average down to that one line. So with step responses, you got to keep that in mind. And I'll talk more about that. If you're interested in really my true opinion of step response tools and what to look at, you're gonna have to wait to the end of the video, and I'll talk about those ins and outs. So keep that in mind, and that's how you can see it in PID Toolbox with this raw. You can see all the different ones here. Some softwares, I like the way they do it better than PID Toolbox for this, and I'll show you that in a little bit. That's the long and the short. You can change this window. There's guides. I really like this, where you can actually click the button here, and it actually shows you the Betaflight slider setup for each of these, which is awesome. I wish other softwares would have this, and they don't. So that's really cool. That's a really cool feature. And again, I'm not going to go through all the pieces with this, but there is a spectrum analysis tool here as well to look at PID noise, or not PID noise, filter, your filter setup and quadcopter vibrations and tweaking your filters out and all that kind of stuff. And a common plot for that is the vibrations versus throttle, and this is the raw, this is the filter gyro, D-term raw. You see how much more vibration comes out because the D-term amplifies it, and then after the D-term filters. So you can see how the notch and RPM filters are taking out the motor band and this resonance spike here, things of that nature. So that's how you kind of use these tools. And again, a lot of these softwares, almost all of them, have these very exact same stuff. There's little tweaks around the edges. Generally, this is the complement of tools they get. There's a filter sim tool, which is really cool to see how filters actually work. I'm going to say that I'm actually the inspiration for this. I think Brian wrote this on his own, but I had Excel files back in 2017 that mapped all the maybe even earlier. I guess it was 2017. That mapped all the filters out and the phase delay between them on, and And so this is really cool. This is a really cool thing. So without rambling on too much, let's move on to the next one. So the next firmware is PID Scope. So PID Scope is admittedly a derivative of PID Toolbox. When PID Toolbox went into Brian's Patreon, people would say behind a paywall, a gentleman grabbed the source code from PID Toolbox and moved it into Octave. PID Toolbox uses MATLAB. PID Scope uses Octave. It essentially looks exactly the same. Works pretty much the exact same. It has the slider tool. It does have the filter simulation. And some of the stuff, I would say the user interface is even a little nicer. So if I look at this, it's just this panel is a little bit nicer displayed in this PID Scope than it is in PID Toolbox. So Octave and MATLAB are not generally software that is made to for distribution. It's more for like university analysis and things of that nature. So we're, when it gets into the graphic-y part, they're a little clunky, and that's why, because they're made for like scientists and stuff and engineers that are like not really hung up about that kind of stuff. They're trying to dig into data and really figure things out. So that's why you see that. Admittedly, one thing with the PID Scope is it is a little slower and more clunky. So it runs a little bit slower. It's not too slow, which is you notice it, than PID Toolbox, but it has a lot of the same features. So you can see here what you get for a step response. This is where it is a little different. Like you can see I'm running that same log, sharp stick inputs only, tuned, and that graphic looks way different than what you get in PID Toolbox. So just putting them side by side, you can see the huge difference between the two. Now there is stuff that I could probably change down here to make it look closer-ish, like the Y correction wasn't turned on, but I shouldn't have to do that at the end of the day, and I'm not gonna go through all the different little things here to see if I get to the same result. So that's a factor. I don't know why there's a differential. If I had to trust one over the other, I'm going to trust PID Toolbox. I'm not saying, maybe the developer of PID Scope can chime in, but it's the same log. I'm getting two different results. So why? And this is something more closely aligned to what I would expect to see. This is a well-tuned quad. And when I look at that versus the untuned, or I should be able to just click on this and hit run, I see that little blip, and that's what this has at default. It has a little bit of an overshoot on the roll axis. If I do the same thing in the PID Scope, you kind of see that, but it's not as straightforward to me because it looks like you have overshoot on both axes. Same data, it's just analyzing it differently. So maybe there's some settings here I'd have to adjust to make that look correctly, but I shouldn't have to do that. Looks like that's the right there, the sharp maneuvers. Looks like it is the one that you'd have to click on. So it's only looking at sharp stick inputs and not all the inputs. And maybe that's the differential there. So you can see up here, if you can see that, I can see it closely. This is like looking at 108 inputs and 88, where PID Toolbox is looking at, in its default, 400 and 483. So it's looking at a lot more inputs there. Now, if I uncheck this sharp maneuvers and let that rerun, now it's even looking at less, 52. I can't even see the other number in here. So yeah, other things in here that might play a factor is degrees per second it's looking at versus the other. Like this is the range of degrees per second it's looking at. So now we're getting up a higher amount. So anyways, again, I'm not trying to vet these softwares for accuracy, and well, to some extent I am, and figure out everything. But those are some of my general observations, that if you're looking at this, don't just accept the defaults. You might need to noodle with it a little bit more and look at your count over here to see that it's giving you a decent step response graphs there. Another thing, like when you run the plots here in the frequency versus throttle, the stuff's not aligned. Like this is the D term. This is the D term pre-filter gyro. So again, that's just a graphical stuff that is a little, like I said, even PID Toolbox is not great graphics wise. PID Scope is very similar. MATLAB and Octave are two kind of analytical softwares that these are kind of based upon, and it's not strong for graphical user interface nicety. PID Scope is one that is free. You do have to download it, and you just run a batch file, and then it runs. You have to have an installer for Octave that it needs to put into your computer as well, which is fairly sizable. So both of those packages, PID Toolbox and PID Scope, are download-based software. The rest of these are going to be web-based. Okay, so this next one is PID Tuna. PID Tuna, again, is web-based. You can see it up here, and I will drop, of course, these links down below. I really like PID Tuna. There's some cool things in it, so let me show you what it's got here. So first of all, it's web-based. I like that. I can just go to the site and go from there and click the logs. You can load as many logs as, well, not as many, but you can load multiple log files here as well and compare them against each other. If you just have one log selected, I like the step response, which is going to be over here under step response. It shows you the different lines kind of faded back, and then shows you that average. So you're mindful and can see if like there's big deviations here, what is based on that average. Like look at the yaw axis compared to these other ones. There's a couple things in here as well. Just like in PID Toolbox, I didn't look in PID Scope, but you can adjust that window size. So you can go from anywhere from 0.25 seconds up to 3 seconds. That's what those milliseconds to seconds conversion is. And I think it was default was 2000, which would be 2 seconds, the same as PID Toolbox. You can also look at the min and max window for step response input. So you can see if I move this down, like this is the minimum that it's excluding. So I'm taking this down to any stepped inputs at 45 degrees per second or and up. It's going to look into that, and you can see how small step inputs makes this kind of worse. And it does have a default here, which you can easily click. Like that's nice that you can click back to the default, the auto. When you click on two logs here, it shows both, and I get what I would expect to see between these two, the tuned and untuned. It's actually a little bit more accurate, it looks to me, for the untuned, where I have this little bit of this oscillation here on the roll axis. That's essentially what this 5-inch gets with just Betaflight defaults. It's a pretty good tune, but it's not perfect. And there's P-term overshoot and flips and rolls and things of that nature. So that's picking that up and showing that. It's snappy, as you can see, and then you can also adjust your window size here if you have to clip some stuff out. You can click full log here and look at the full log if you don't want to clip things out. There's a scorecard tool in here, so you can kind of see what it's seeing as good and versus bad. So this is the tuned log, and it's saying, hey, everything looks pretty good here, which is accurate, except for motor balance, which is also accurate. The motor balance isn't great, and I'll talk about that in a second. It also has available here that you can see that the default is okay. It's yellow. It's basically saying your step response and your tracking, your rise time, your overshoot, your latency aren't great. They're mid. You know, they're yellow, right? Which is accurate. You can click on these things and it takes you right to the window that it's kind of talking about. So it's kind of neat for a heads-up analysis of what you may want to look at and consider. There's tracking plots, just like in PID Toolbox and the other things I talked about. You can look at the raw. You can look at just the PID terms themselves. There's like 1,000 different ways to look at different little aspects of it. There's an iTerm saturation tool where you can see if your iTerm, it's not such a thing for Betaflight anymore, but it could be for like KISS or even iNav, probably definitely ArduPilot, I would think, to see if you're getting iTerm saturation, where basically you're leaning too heavily on iTerm to keep the thing in balance. There's a motor analysis tool here as well that will look at your different motors and seeing if you're getting to motor saturation with your inputs. So if you see a lot of it, you're going to have a bad step response graph or bad tune just because your quad is underpowered. Your motors are too small for the weight or rotation. Again, for 5-inch quads, it's hardly ever happens. It's not that big of it, although it is a thing, and I'll show you that. For big quads, that's a big deal because we're skipping over that a lot. Like, hey, are your motors saturated? Because that overshoot you might see in that step response, that could be just because your motors can't keep up. You're not tuning that out. You need bigger motors or reduce the moment of inertia on this craft somehow, or reduce your rates. Pick one. Motor balance tool. Now, this is off on this specific log. You can see here, it's on this top log here. I don't know why it didn't pick this up correctly. It's not that out of balance. This is more closely accurate. It does do a better job. I don't think it was this tool. It was probably another tool at showing that, hey, the back motors are working harder than the front motors on this quad, and then they do, and that's semi-normal, but it's not ideal. There's nothing I can really fix on it. It is what it is. I already have a GoPro in the front, so the back motors are, just because the thing's going like this and it's pushing forward that way, it's the back motors just work a little bit harder, but it's not wrong about it, which is that's good input. There's a nice little GPS function here that you can actually, if you have your GPS on, like I do, and it logs that now in the latest beta flight, you can actually play through and see the quad and where it went and all that kind of stuff, which you could use for different things if you want. We already talked about the step response tool. There's the latency in here that can show you latency information. I didn't really dig into this too much. There's some full spectrum information here. The sim filter stuff is here as well. I don't think this works exactly right because I'm seeing things like that. I don't know that the filter sim stuff's that widely used anyways, but that outside, so I don't know that this is great and working well. There's spectrogram tools in here as well. Probably, I would say, not as nice as PID Toolbox or the other one. This is kind of the full flight log. You can change this to raw, and this is kind of the motor trace, so you can see the vibrations. Like, this is throughout the entire flight, and you can see the motor like this is a ramp up to full throttle, dropped, ramped up to full throttle, dropped, and then this is all the different this is basically the motor noise up here. You can see where there's resonance spikes kind of throughout the flight as well. I don't know that this is too helpful, but that's what it is. You can change some things on here to make it a little bit more fine fidelity in what you're seeing down there. Again, another spec for motor trace stuff and vibrations, and then some tuning settings down here. If you have one log selected, it just looks at that information. If you have two or more logs selected, probably just two, it kind of shows you some differentials between the two logs that you have turned on there. And then you can also hit differential here and kind of see the differentials between those two logs as well. So like if I turn off one of the logs, I don't get a diff, but if I turn on that, you can see like, oh, this log has higher, red is decreased, green is increased. So green in this case is kind of bad. You have more latency in the default than you do in the tuned one, things like that. So like I talked about, a lot of information. It's quick. It's web-based. You can bring it up. I like the step response piece probably the most. I think it's a quick way to look at step response. You can load up the stuff. It's snappy, and motor balance looks fairly good there, except for that one example where it was off for some reason on that one log. But yeah, I think PID Tuna is a pretty good free web-based solution to check out. Okay, the next one is going to be PID Pulse. So PID Pulse is also a web-based solution. It's one log at a time. You can click on it and then hit and open that log, and it will show you the step response. Again, here, let's just look here. I don't love what I'm seeing for the step response here, as you can hopefully have a mind's eye of what the default looked like before. This is like awfully wavy. Now it should have this overshoot because this is the default, and there's not a lot. I don't see any things that I can really adjust here to adjust any of that. It's kind of, that's what you got. So not as adjustable as the PID Tuna, PID Toolbox, or the PID Scope. You can click into here to see the individual step responses. So that's good. You can just click that button on each one of them. And there is some, you can kind of change the window size here to see, kind of zoom in up front. You can look at one axis versus another. You can share your analysis stuff with somebody, so that's pretty cool. There is a drop down here to look at throttle versus noise, and it will do the spectrograms and spectrographs and stuff like that for that. So that's kind of what that looks like. And there's a number of other things, time versus noise, D-term, RPM noise, a bunch of stuff with noise. It does look at motor balance, and here I'm looking at the default. It's basically saying here, this was the one that shows that the pitch axis is, off balance here. And it talks about the rear motors are working noticeably harder. The FC is holding the nose up. The GC sits somewhere aft. And so that's cool. Like, it gives you some input here on that. It has a high confidence level, supposedly. So that's a neat analysis that it has there. But going back to the step response on this, I think one of the coolest things that this has is you can actually hit calculate PIDs, and it will, and this can take some time. I've already clicked it on this, but this can take some time, like multiple minutes, maybe 5. It can take some time. I've noticed sometimes, but this will allow you to say, hey, this is the current, and then you can make adjustments to this to say, what if I make these PID setting changes? Will it, what would it change to? Basically saying, it's essentially saying my I term is too high here. So that's very cool. I love that. And then you can hit this find recommended PID. So you may say, well, this is not just a PID analysis. This is a PID tuning software. It's like, yeah, well, this isn't that accurate. So it's very cool, but if I switch my PIDs to the tune PIDs, so this is the default. Let me go and put in what my tune PIDs are, and you know what that looked like. It looked like this perfect step response in PID Toolbox and in PID, well, not so much in PID Scope, but in PID Tuna and the other ones. And we'll see what if I put those PIDs in here, that should show me that same really good step response. Let's see what it actually gives me. So now I've input the tuned PIDs, and you saw what those step response looks like, and this is what it's telling me. So this doesn't really lead me to like the tuned quad. I think the biggest thing that this is probably missing is that Betaflight has I-term relax. So I-term relax basically negates the I-term overshoot when you do sharp stick input. So this may be more accurate if you would have that turned off, but nobody has that turned off. It's not turned off by default. Why would you ever turn it off? So that's my guess of why this is off. You can also hit recommended PIDs here as well. Again, this can take a little bit of time, but I'm telling you too, it's not going to come to these numbers, and it doesn't, it's not coming up with a great tune to be input to begin with. So here, after waiting probably a minute or so, this is the PID tune it's recommending, which is odd because it's still showing like an overshoot here, but this isn't, that's not right. First of all, the D term on the pitch needs to go up for overshooting issues. Yeah, this would just be chasing. I mean, you just be chasing your tail. Now, to the defense, this is uses for guidance only, check, safety check, all that kind of good stuff. So very cool concept. I like this thing where it can do that and you can move stuff around. I just wish it worked a little bit better. But yeah, go check it out. I think it's worth your time to at least explore it and take a look. Again, it's web-based. It's pretty easy to click on it, load a log, and nuts around with it yourself and see what you think. Now, the final one here is PID Lab. So PID Lab is another tool, web-based. You can see the link up top here. You can also, it's a web app, so you can click it here and it would, put a little cached version on your computer so you could use it without the internet. It has a little dashboard so you can load your log. Some things with this is I've noticed that it can take a while to load a log. Like some logs just load right up, but Betaflight 2026.06, they take a while to load, like a couple minutes. And I don't know why. I don't know. My sample frequency was semi-high on them. Maybe it's that. I don't know. But the other ones don't take that long to load them. And you can see once you load a larger log, or I don't know, just a log with, I don't know why it's taking longer on these. I don't know, I wouldn't say a larger log necessarily. It's kind of really sluggish to move around here. So let me pause for a second. Well, long story short, with PID Labs, it does at the top say this software is under development and may contain bugs. So I'll give it that. And it was something just sent to me as a trial, check it out. It's free, it's online, you can see the web address up there. I have trouble just getting logs to load. Some of them, once they load, it's really sluggish to move through the program. It does give recommendations based on what it sees, but the recommendations are, I think, AI slop. Like the one, it was like, there's high prop wash detected. Turn your D gains down, set your, oh, here we go, finally. Turn your D gains down, set your some other stuff. And it, like here, severe prop wash on the yaw axis for like not a normal thing. But then let's go set your D gain to 0 on yaw, set your dynamic idle to 30, and then turn up your feed forward smoothing factor. What the heck does that have to do with prop wash? That's most likely not on the yaw axis. It's not prop wash based on the yaw axis. Prop wash is like oscillating down through it's basically the airfoil of the prop messing up, and your yaw axis doesn't use that. It's using moment of inertia and drag, wind drag. So it's just, yeah, these aren't good. So I think these are kind of AI slop. It has all the other normal spectrograph stuff. It's not that great. You can see here the spectrograph is not like, this is the SEP response from this log. This is not my log. This is some older log that I got from helping somebody tune. So this is not really good. I did load my own logs before and they were all shaky like this. Again, you could probably like change stuff in here and tweak stuff to get it better. But I shouldn't have to do that. I shouldn't have to know like custom settings nobody's going to know that stuff. The default should be pretty good. And then if you're tweaking stuff up here, it should be like more advanced things that you want to look at. So not a really good one here. So as promised, I told you I'd tell you what my favorite is. My favorite for tuning is I use Blackbox Explorer. And the reason it's free, it's in Betaflight Configurator now. It has some features the other ones don't have, like, for example, not many features, but one that I like a lot is that in the spectrographs, you can run frequency versus RPM versus frequency versus throttle. And you can see that it makes a difference. Like you can see that straight line linear response that you get versus RPM versus throttle. It's like this curved response. So you can see that we do get a pretty linear response with our RPM increases for our quadcopter. It's really just the throttle to the frequency that you get a kind of a curved non-linear response. So like that's a little feature. I think the biggest thing is that when you're looking at your stepped inputs, what you can kind of see look like the same step response thing. Like if you're looking at step response, well, this is the step response, right? Going up and to 1 and across. This is that step response right here. You can see a lot of stuff with this, like it's going up. We have barely a little, this is untuned, barely a little overshoot, but then there's like a little bit of wobble. Now it's rotating at full rate rotation, and you can see we have some overshoot. Most importantly, that when you look at stick tracking all by itself, you can look down here and look at this part of it. So if I zoom in and I do my exaggeration, you can see here and confirm things like, hey, this overshoot that we have down here, is that because the motors can't keep up? The answer is no, because you can see we're not the motor commands aren't at 100%. So it's not oversaturation of the motors that is making this overshoot. It is just tuning is the problem. Vice versa. Can you see here the same thing? Like, why is there this big delay? I can tune that delay out with feed forward. No, you cannot. You can make it a little bit better, but you're not going to tune it all the way out. Why? Your motors are fully saturated right here. You might be a little bit better, but you're not, once you crank up feed forward and whatnot, to some extent, that's as good as you're going to get it. Feed forward does help because it makes it enter the move faster. But if you have your feed forward up, I don't have feed forward on here. If I had feed forward up and I was tweaking that, I could see, like, am I chasing the rabbit? Am I hitting motor saturation all over the place? If I am, that's as good as you're going to get. Unless I put bigger motors on or reduce the moment of inertia. So that's a huge thing to me, Blackbox wise, that you can just see all that here. It's like all heads up information right away. You're not looking at like having to interpret graphs. You're just looking at it right here. You're basically looking at I would say, raw data. Outside of that, like I said before, Brian White's with PID Toolbox, of course, and off the service, if you're looking for a high level of service, that comes along with his Patreon. And the PID Tuna. I think the PID Tuna is really cool just for a quick, I like the interface. It's snappy. I like some of the features of the interface I talked about. So that is my roundup for PID analysis software. In the next video, we're going to talk about PID tuning software, where they give recommendations. So that will be a hot take. Are the recommendations good? I am skeptical that they will be good. Just, AI speaks with confidence, confidently wrong, and chase your tail. So, but a lot of people do swear by it as well. You'll see out there. So we'll be checking them out. If you want to make sure you don't miss that, go ahead and make sure you're subscribed down below. Links to all these are available down below, and also the playlist as well for this whole series. Thanks, everybody. We'll see you in the next one.